Automated systems exist because there are jobs humans do badly. Watching a dial for 8 hours and noticing the moment it moves is a task people are genuinely poor at. Attention drifts, and the important reading arrives at 4 in the morning. Reacting within 100 milliseconds is impossible for us. Taking a measurement every second for a year without missing one is not something a person can do, and some places simply cannot be occupied inside a furnace at the bottom of the sea in a reactor. So the argument for these systems is not that they are cleverer than people, it is that they do not get bored, do not get tired, and do not need to be anywhere pleasant. Now the distinction this whole section is examined on, and it is a single difference. A monitoring system takes readings and reports them. It records data, displays it, or raises an alarm, but it does not change anything about the physical conditions it is measuring. A control system takes readings and acts on them, changing those physical conditions. Both use sensors. Both use a microprocessor. Both compare against a stored value. The only difference is whether there is an actuator on the end doing something about the answer, which gives you a reliable test for any scenario. Does the system change the thing it is measuring? If yes, it is control. If it only reports, records, or warns, it is monitoring. Let me run the same situation through both because that is what makes the difference concrete. A patient monitor in a hospital measuring heart rate. First, as a monitoring system, the sensor takes a reading. The patient's heart rate is 130 beats per minute. The ADC converts it to digital. The microprocessor compares it against the stored safe range. It is above that range, so the system displays the value on screen and sounds an alarm to alert a nurse, and then it repeats. Notice where that stopped. The system informed a human, and the human decides what to do. Nothing about the patient changed because of the machine. Now the same reading in a control system, an infusion pump delivering a drug that affects heart rate. Identical first 3 steps. Sensor reads 130, ADC converts, microprocessor compares against the stored range. But now the 4th step is different. Instead of alerting somebody, the microprocessor signals an actuator. It adjusts the pump, changing the dose, and then it repeats. And on the next pass, it reads a heart rate that its own action has altered. That is the loop closing. The system is now affecting the very thing it is measuring, which is what feedback means, and it is why control systems are the ones that can hold a value steady, while monitoring systems can only report it drifting. The components and the strictness about which does what is not pedantry. It is where marks are lost. The sensor continuously measures a physical quantity and sends readings. It measures, and that is all. It does not decide and cannot switch anything on. The analog to digital converter turns the sensor's analog signal into digital because the processor cannot accept an analog 1. The microprocessor is the only component that compares anything. It takes the digital reading, compares it with the stored preset value, and decides. The digital to analog converter appears on the output side where an actuator needs a varying analog signal, not always, as we established in 3.2. And the actuator carries out the physical action, a motor, a valve, a heater, a pump. If you write that, the sensor turns on the heater when it gets cold. You have given the sensor the microprocessor's job, and that is a mark gone every time. Take the street lighting example on the page and work it properly, because this is exactly the shape of an exam answer. A light sensor continuously measures the ambient light level. Its analog reading is converted to digital by the ADC. The microprocessor compares that reading with a stored preset value representing dusk. If the light level is below the preset value, the microprocessor sends a signal to switch the lamp on. If it is above, it switches the lamp off, which handles dawn without any extra logic, and the process repeats continuously, so the lights respond to a cloudy afternoon just as they respond to sunset. Is that monitoring or control? It changes the physical conditions, so it is a control system, and notice one subtlety worth appreciating. The lamp it switches on affects the light level, so a badly placed sensor could see its own lamp, decide it is now daylight, and switch off, then dark again, so on again. Feedback that is not thought through produces oscillation, which is a real engineering problem and the reason such sensors are positioned to face away from the lamp. So how do you tell which one a question is describing? Look at what happens after the comparison. Words like display, record, log, alert, warn, notify, or sound an alarm mean monitoring. Words like adjust, switch, open, close, increase, maintain, or keep at mean control. And be careful with an alarm because it catches people out. An alarm is an output, and a buzzer is arguably an actuator, but sounding an alarm does not change the condition being measured. A burglar alarm system measuring whether a window is open and sounding a siren is monitoring. The siren does not close the window. If a question describes a system that keeps something at a value, that is control. If it tells somebody about a value, that is monitoring. 4 things to take into the exam. First, the difference between monitoring and control is whether the system changes the physical conditions it measures. Say that. Do not just give examples of each. Second, keep the components' jobs separate. Sensor measures, microprocessor compares and decides, actuator acts. Third, in any description of operation, include the ADC and say that the process repeats continuously. Both are routinely omitted and both usually carry a mark. And fourth, name the preset value explicitly as the thing the reading is compared against. Get those 4 in, and a description question in this section is close to fully answered before you have said anything specific to the scenario at all.